These are the solutions to this week's Check for Understanding. For each of the following, describe how the graph of the function is a transformation of the original function f of x. So for A, we see that we've added 3 to the input value. This means it's going to shift the graph horizontally. Because we're adding, it's going to shift it to the left 3 units. For B, again, we're affecting the input value, so it's going to be a shift horizontally, but this time since we're subtracting, we're going to be shifting horizontally to the right 3 units. In the third one, in C, we're adding to the output. Adding to the output shifts the function vertically. So this is going to be a shift vertically. And because we're adding, we're going to be shifting up, and we're shifting up 3 units. Whenever we multiply the output by a number, it's going to be a stretch vertically. Whenever we multiply the input by a number, it's going to be a compression or squeezing horizontally. And finally, the last one has 2 moves. We're subtracting from the input, so that's going to shift it horizontally. Because we're subtracting, we're going to be shifting it to the right 5 units. And then, because we're adding 2 to the output, then we're going to be shifting it up 2 units. So that's a summary of function transformations. For 2, given the graph of f of x, sketch the graph of f of x minus 2 plus 1. So just like before, we have to think about how the graph is going to be different. It's going to be shifted to the right 2 units, and then it's going to be shifted up 1 unit. So we're going to take this v, the graph of the absolute value function, and the vertex, instead of being at 0, 0, is going to be shifted, like we said, to the right 2 units and up 1 unit. So that'll be the new vertex. We're not multiplying by anything, and so the slopes of the lines are going to stay the same, and so this would be the graph of the new function. In the next section, we're going to be taking a look at absolute value equations and inequalities. So for 3a, we have 2 times the absolute value of 2x plus 4 is equal to 8. We need to get the absolute value sign by itself, so we'll divide both sides by 2. That gives us the absolute value of 2x plus 4 is equal to 4. And now we're going to set up 2 equations. Absolute value, remember, means distance from the origin. So the 2 numbers that are 4 units away from the origin are negative 4 and positive 4. And now we're simply going to solve each of these equations. So subtracting 4 from both sides and then dividing by 2 gives us one solution, x equals negative 4. Subtracting 4 and then dividing by 2 gives us our second solution, x is equal to 0. For b, we're going to start by getting the absolute value sign by itself. And to do that, we're going to start by subtracting 6 from both sides. That tells us that the absolute value of x plus 5 is equal to negative 4. But if we think about the definition of absolute value, we know that absolute value cannot be negative. So this equation has no solution. Now let's take a look at inequalities. So for the first one, the absolute value sign is by itself, so that's a great place to start. And now we have to think about the number line and think about the numbers that are more than 4 units from 0. So if we think about what numbers those are and where they fall, the numbers that are more than 4 units from 0 are here or here. And so that gives us two inequalities. 3x minus 5 is less than negative 4, or 3x minus 5 is greater than 4. If we add 5 to both sides and divide by 3, here is our first solution. If we add 5 and divide by 3, here's our second solution. And so if we think about what the graph of that looks like, the graph of the solution set looks like this. Here's 1/3. Here is 3. The graph of the solution set looks like this. And so we'll need two intervals to describe the solution. Here we have from negative infinity to 1/3. And here we have from 3 to infinity. And they would be joined together with a union sign. For the next one, for B, so this is for A, for 4B, we're going to do the same thing. The absolute value of 2x plus 4 minus 5 is less than or equal to 7. We'll get the absolute value sign by itself. Absolute value of 2x plus 4 is less than or equal to 12. If we think about where the numbers are on the number line that are less than 12 units from 0, we could draw a picture of where they would lie. Those numbers would be in here. And so let's write two inequalities that describe that region. Those numbers are greater than or equal to negative 12, and those numbers are also less than or equal to positive 12. We're just going to go ahead and solve these by subtracting 4 and dividing by 2. And the same on this one. We'll subtract 4 and we'll divide by 2. If we were to graph that solution set, it would go from negative 8 to 4 and would look like this. And in interval notation, we would write it like this. The last ones are about inverses. Are f of x equals 3x plus 2 and g of x equal to x minus 2 divided by 3 inverses? Why or why not? Well, one way to test that would be to see what would happen if we plugged in a number. So for example, is f inverse of 1 equal to 1? And does it work in the other direction as well? So that would be one way to check. And another way to check would be to simply find the inverse of f of x and see if we get g of x. I think I'm going to do it that way because that will also help us know how to do number 6. So we're going to say, what is f inverse of x? Well, the way we do that is we start with f of x. And we're going to use y notation instead of function notation. So y is equal to 3x plus 2. And in the inverse process, x and y change places. So we would have this. And then what we would do is we would solve for y. Solve for y. So we'll subtract 2 and divide by 3. And that gives us y. And that's exactly what we have here. So the answer is yes. We're going to use that same approach for the last problem. So we're going to find the inverse of this function. So we're going to start with f of x is equal to x over x minus 5. We're going to use y notation instead. And now we're going to make the inverse. So when we make an inverse, y and x are interchanged. So we have x is equal to y over y minus 5, and now what we need to do is solve for y. To solve this rational equation, we will multiply both sides by the denominator. So we're going to multiply both sides by y minus 5. So that's going to give us xy minus 5x is equal to, these will cancel, and here we have y And what we're trying to do is we're trying to solve for y. So if we want to solve for y, we'll add 5x to both sides. So xy is equal to 5x plus y. We'll subtract y from each side. Xy minus y is equal to 5x. And we're almost there. We factor out the common factor and then divide. So y is equal to 5x over x minus 1. And this is the inverse of function f. So that's the solution to this week's problem set. And I'll be posting that then for you to check your work.